Okay, so 64 is an extension from 63. And I'm going to draw the picture with you as well. Okay, and then so if you need to adjust yours, feel free to do that. So here's the picture that the book gives you. And it says that this boater in exercise 63 wants to arrive at a point on the north shore of the river directly opposite the starting point. In what direction should the boat be headed? Okay, so what I'm going to do is I'm just going to recreate this picture that they gave me in 63. Okay, so we have the current that's flowing towards the east.
This way, Paul. This way.
That was a beautiful one.
Thank you. That is the river.
Absolutely stunning.
And this is going to be the boat. Alright, and then this is your 60 degrees. Here's your little boat. Okay, so it says a point that's directly north of the starting point. So that we can visualize this correctly, remember, they're drawing this boat in the middle of the water. Okay, so we have to imagine where this boat started from on the shore. So what I did is I kind of drew the path and said, okay, if it's going at 60 degrees, then the boat started on the shore somewhere in this region, right? So it took off from the shore here,
How?
well, because it's going 60 degrees.
I know, but like, I thought they were saying the axis was the shore.
That's what I thought too.
That's what I thought they were saying. I was like,
Right,
this doesn't make
right,
sense.
and that's why I'm saying that I thought the wording was a little bit confusing. So with this, if you just follow that vector that represents the boat, okay, if this is the shore, if we want to head to a point that's directly north of it, we're going to head somewhere in this direction. So this is where the boat was headed in the original drawing. Now we're going to adjust it. So this is going to be our new vector. And this is the theta value that we're trying to find.
Oh.
Okay, so I'll just write out again how I got that. So if you're thinking of this as the east, knowing that I'm headed somewhere north of my original starting point, what you're trying to find is your theta value. Now, even if you didn't realize that it was more in this direction, even if you put it like straight up north, your values would still come out the same. It's just better to have a visual picture of what's going on so you can understand that this is going to be the boat and then this is going to be the river.
So for questions where they ask if he wants to change directions or whatever, is this like how it is? We just follow it back?
So yeah, whenever it's asking you what direction should the boat or the pilot head, what you're going to be finding is your theta value.
The different. So basically, you're drawing a vector to the place that they want to go
Yes.
from their starting or from their original vector.
Yes, and we're going to practice that today as well.
Okay.
So our river is still going to be the same. So our river is still flowing with a horizontal component of 10 and a vertical component of 0. And now our boat, because remember in 63 we already found that vector, the only thing that's different now is we don't know theta. Before theta was 60, now theta is unknown. So it's still going 20 miles per hour, but this is going to be our unknown. Okay, so what you're going to have is an expression that represents the vector of the boat.
Oh, yeah.
Okay, and again, that's because you're trying to find the angle that the boat is going. And you're not using this 60 degrees anymore. The boat's not going that direction. Now the boat's heading to a point directly north of the
So
shore.
it's negative.
So do we have to use like the
So you'd be
Pythagorean?
going west.
Well,
going that
we
direction.
are going to be going towards the west, but that'll come out when we find theta.
Never mind.
Okay, so what we want to do is we want to find the resultant vector, which your resultant vector is going to be the boat plus the river. And if I add those together, again, I'm going to get an expression. So when I'm adding my two horizontal components, what I have is 10 plus 20 cosine of theta and 0 plus 20 sine of theta.
Is that
Okay, so what I'm doing is I'm just adding these two together. So I'm adding the two horizontal components and then I'm adding the two vertical components. Okay, so what I have is an expression. The next part, we're going to talk about that a little bit logically. So we want to head in what direction?
north, right?
Yes, north. So if you want to head north, there's going to be something that we know. So we're going to talk about this. So let's say I want to head north, okay? We'll say this is me heading north. What type of forces would push me away from heading north?
East or west?
East and west, right? Because if I'm getting a wind from the west, it's going to push me towards the east. And if I get a wind from the east, it's going to push me towards the west. So that means that my east and west component, I want to be 0. Because if my east and west component is 0, then I'm going to be headed north and there's no force that's going to push me off of my track. So let's think about what component is the east to west component. So if I'm going east to west, is that horizontal or vertical? Yep. So what I can deduce from this situation is that my horizontal component has to be equal to 0 if I'm going north. Okay, so if I'm going north, my horizontal component has to be equal to 0. So if you look at your vector, this is going to be the horizontal component. So what I can do is take 10 plus 20 cosine of theta, set that equal to 0, and then I can solve.
4 theta.
That's what I meant with
Yep.
it when I said -10. Because
Oh, okay, yes,
Yeah.
because when you're setting it equal, it'll be
Yeah.
negative 10. I gotcha. Okay, so now what we're going to do is subtract 10 from both sides. And we'd have 20 cosine of theta equals negative 10. Divide by 20.
See, I just started there because I plugged it into the formula.
Yeah, that's okay.
Yeah.
And so did you end up with the cosine of theta equals negative 1/2?
Yeah.
Okay, and then your theta value, what did we get?
30 degrees west of north.
Well, for theta.
Oh, I
That's okay,
120.
I know. Or, because I need physics.
No.
Oh. Have you ever been?
Huh?
Have you ever been?
No.
Oh, okay. Okay, so when you solve for theta, did some of you get the 120 degrees? Okay, so whenever you get this angle is going to be your north of east. So if you're looking at this on a compass, right? North, east, west, south. This would be your 120 degrees. Now, you don't want to say to the pilot to go 120 degrees north of east, because what direction are we really heading?
West.
Yeah, you're heading northwest, right?
West.
Okay, so then, Megan, how would we know that I could use 30 degrees?
Well, because 120 minus the 90, which is the first quadrant, equals 30.
Exactly. So then this is going to be 30 degrees, and now I can either write my answer as
You could do 60 degrees north of west, or 30 degrees west of north.
yep. So you can do north 30 degrees west, 30 degrees west of north. West 60 degrees north is fine, and then I think you said this one, north of west, 60 degrees north of west. So any one of those answers would be acceptable.
So, in physics, we use the tangent. So I got 26.57. Is that close enough, or you want me to learn this way too?
How would you learn it your way?
Why, you're gonna stand up?
I don't know.
No, Abby helped me.